Hello, good morning students. Today we are going to deal with a new chapter, thermal properties of matter. You feel hotter on a sunny afternoon as compared to windy night. This is because of the difference in temperatures. And temperature is very high in the afternoon as compared to night. So we feel hot when the temperature is high, we feel cold when temperature is low. So in this chapter we are going to deal with hotness and coldness, high temperature, low temperature. So this chapter mainly deals with heat and temperature. Information about thermal properties of matter, where we will study about the properties of different substance by virtue of heat or heat transfer. In simple terms, we can say that when temperature is more, heat is also more, and when temperature is less, heat is less. So temperature is something that is dealt with the amount of heat. Okay, so heat and temperature are different entities. So let us see what is heat and what is temperature. Heat is a form of energy which is transferred between two or more systems or from system to a surrounding. Heat is the form of energy, and heat always flows from hot body to cold body. And heat produces the sensation of hotness or coldness. So when I tell about hot, I am feeling hot, that means heat is more. So I am talking about energy. Okay, so heat is actually the sensation of hotness or coldness. And heat will flow, heat will be transferred from system to surroundings or between two systems by virtue of the temperature difference. So only if there is a temperature difference, heat flow will take place. And we already know heat is always flowing from high temperature to low temperature. Example, a cup of hot coffee can be considered as the object or system. I am taking a cup of hot coffee, that is considered as our system. Apart from that, anything apart from the hot coffee is considered as the surroundings. So I am keeping coffee here, that coffee is our system, and everything surrounding that will be the will be considered as the surroundings. And what will happen? Usually the surrounding temperature will be lesser than the hot coffee temperature. We know our room temperature will be like 25 degrees Celsius or till 30 degree. It's an average 25 to 30. So that is the surrounding temperature. And hot coffee means it will be above 50 degree, 50 or 60 or 70 degree. So the system is more hot than the surroundings. System is hotter than the surroundings. So what will happen? Heat will flow from system to surroundings because there is a temperature difference. And till what time the heat will flow? The heat will flow only till both of them attain thermal equilibrium. That means heat will be transferred till the system and surrounding achieves same temperature. That is called thermal equilibrium. System and surrounding achieves same temperature. That is called thermal equilibrium, and at that time heat transfer will stop. So here I have written, after some time we will see this hot cup of coffee will become cold as there will be transfer of heat, and that heat transfer will take place till the temperature of the system and temperature of the surroundings are same. That is called thermal equilibrium. SI unit of heat is joule, and some of the other commonly used units are calorie and kilocalorie. Those are the CGS units. SI unit is joule, and commonly used unit is calorie and kilocalorie. Relation between joule and calorie. 1 calorie is equal to 4.18 joules. So if you want, you can round off to 4.2 joules and do the sums. So 1 calorie is 4.18 joules, and 1 kilocalorie is 1000 calorie. That means 4180 joules. Now let us see what is meant by temperature. So we told heat is a form of energy which causes the hotness or coldness. It is the sensation of hotness or coldness, and heat is a form of energy in transit. Transit meaning heat always flows. Heat cannot be steady. Heat always flows, and it flows from hot body to cold body. That is what you studied. Now what is meant by temperature? Temperature is defined as the measure of degree of hotness or coldness. Temperature is the measure. Okay, temperature is the measure of hotness or coldness. And example, a cup of hot soup or a scoop of ice cream. We know this is hot, that is cold. So if we measure the temperature of the hot soup, the temperature will be high, and if we measure the temperature of the cold soup, cold ice cream, it will be very low. So we can measure the temperature just to understand whether it is hot or cold. That is why it is the measure of hotness or coldness. And what are the units of temperature? SI unit of temperature is Kelvin, but some of the commonly used units are Fahrenheit and Celsius. So Fahrenheit is written as degree F, and Celsius is written as degree C. Okay, degree Fahrenheit, degree Celsius. So those are the other units. Kelvin is always used in the laboratory, whereas Fahrenheit is used by doctors to measure the body temperature, to check whether we are having fever or not. And degree Celsius is commonly used, it is used by doctors, and it is used by the common man to measure the temperature of certain substance. And we know what is the normal body temperature, 37 degrees Celsius. So we are telling everything in degrees Celsius only. That is the unit which is commonly used by man. Now measurement of temperature. Temperature is measured with the help of thermometer, and inside the thermometer you can see there is a bulb and there is a glass tube, and in that glass tube either we will fill mercury or we will fill alcohol, and both of them, mercury and alcohol, both of them are visible, and their expansivity is also very high. They will expand for even a very small rise in the temperature. So their expansivity is also very high. So to construct a thermometer, two fixed points are to be chosen as the reference points, and those fixed points are known as the freezing point or the ice point and the second one is boiling point or steam point. So the water freezes and boils at these 2 points under standard pressure. So to construct a thermometer, we need to know about the melting point and the boiling point of water, that is used as the standard to construct a thermometer. Now there are 3 types of scale that we use. Just now we discussed Kelvin scale, Fahrenheit scale and degree Celsius. So in Fahrenheit, the ice point and steam point are 32 degree Fahrenheit and 212 degree Fahrenheit respectively. 32 is the ice point, 212 is the steam point, and it has 180 divisions. Okay, it has 180 divisions between 32 and 212. Now in degree Celsius, it is 0 degree Celsius as the ice point and 100 degrees Celsius as the steam point. That you already know. Water becomes ice at 0 degrees Celsius and water boils at 100 degrees Celsius. So it is 0 degrees Celsius and 100 degrees Celsius for the ice point and steam point respectively. So how many number of divisions are there? 100. So here I have just mentioned the thermometer with a Fahrenheit scale on this side and degree Celsius scale on the other side. Now Kelvin scale, the third one is Kelvin scale. On Kelvin scale, the values are 273.15 Kelvin and 373.15 Kelvin for the ice point and steam point respectively. So 273.15 Kelvin is the ice point and 373.15 degree is the 15 Kelvin is the steam point. So how many number of divisions are there? Here also 100. So I have just given a graph which shows the relation between the temperature in Celsius and Fahrenheit, difference in temperature between Celsius and Fahrenheit. So the graph is a straight line and you can see at 180 degree Celsius and the Fahrenheit scale is coinciding. So here I have written 180 degree Celsius and there I have written 180 degree Fahrenheit. Now how will we convert? Temperature scales from one point to another? That is what we are going to see now. TF stands for Fahrenheit, TC stands for Celsius and TK stands for Kelvin. So I have made the equation relating the steam point and the ice point. So here you see TF minus 32. 32 is the ice point. So TF minus 32 divided by number of divisions. And degree Celsius, TC minus 0 because 0 is the ice point. TC minus 0, that is TC itself divided by number of divisions, 100, equal to TK minus 273.15 divided by 100. So if I want to convert Fahrenheit to degree Celsius, take these two equations, TF minus 32 by 180 equal to TC by 100, and you can convert from one to another. If you want to convert Fahrenheit to Kelvin, take the first equation and the last equation. So TF minus 32 by 180 equal to TK minus 273.15 by 100. So equate both and you can interconvert from one point to another. Okay, so that's all in this section. Thank you.